I will present to you about my research on improvement of compressibility characteristics of waste material by dynamic compaction. This is the content of this presentation. Sri Lanka generates about 7,000 metric tons of solid waste per day, and open dumping is the most widely used method of waste disposal. These landfill sites are located in urban areas and are very valuable, so they have to be rehabilitated and converted into parks, roads, and other construction projects. When developing these sites, it is important to consider various geotechnical characteristics such as the shear strength and compressibility. And in our research, we focused on improving the compressibility of solid waste. Settlement of municipal solid waste occur in several distinct phases. Primary compression contains a physical compression of particles such as dissorption, bending, crushing, particle orientation, and consolidation. And this occurs due to the self-weight of the waste or application of surcharge, such as fill over time. And secondary compression occurs due to the creep and biodegradation process in the waste. As given in the table, many countries have used dynamic compaction to successfully compact waste fields, but in Sri Lanka, dynamic compaction is not used, and suitability of this method to compact municipal solid waste in Sri Lanka needed to be studied. And this is our research problem. So in order to rehabilitate waste dumping sites, their compressibility should be reduced. Preloading has shown to be effective in reducing the compressibility of waste material, and dynamic compaction could be an effective method to compact thick layers of waste material, and effectiveness of this technique needed to be studied. And these are the objectives of our research. Study the compressibility characteristics of waste material which were obtained from sites currently used as waste dump sites. Study how the compressibility characteristics of waste material can be enhanced to suit the proposed developments using dynamic compaction, and to compare the effectiveness of the dynamic compaction process with that of preloading in enhancing the compressibility characteristics of waste. So moving on to the methodology, municipal solid waste samples were collected from Meethatamula landfill sites and prepared in order to carry out the testing. And the dynamic compaction in the laboratory was simulated using an arrangement like this. So dynamic compaction through pre-polling of the weight was achieved using an electromagnet and a pulley mechanism. A weight of 31.8 kilogram was dropped from a height of 1 meter on the waste 20 times in order to achieve compaction. So weight was lifted to top again by a rope. And this was how the compaction was done. And the depth of improvement of municipal solid waste by dynamic compaction is given by this equation. And according to it, the achieved depth of improvement in our study is 84 millimeter. And as a sample thickness, about 50 millimeter was used in our study. This depth of improvement was adequate. And the compacted sample was extruded using a cutter and put in the row cell to test under loading and unloading. In addition, another non-compacted samples was also tested inside the row cell under the loading, unloading, and reloading. Reloading in the non-compacted sample represent the behavior of the municipal solid waste subjected to preloading. Finally, the results were analyzed to establish the characteristics related to compressibility, such as coefficient of volume compressibility, compressibility index, coefficient of consolidation, and coefficient of secondary compression. And the results were compared to assess the effectiveness of the dynamic compaction and preloading. And this is the composition of the waste sample we used in our study, and it is established considering the weight of each material type. And next, the basic parameters of the solid waste samples in our study were established, and it can be seen that dynamic compaction has clearly improved the density of the waste. Moving on to the compressibility characteristics, the shapes of the settlement curve showed a plot of similar gradient as seen in PT clay, clearly indicating that municipal solid waste have a high secondary consolidation settlement. And these are the E versus log sigma curves for compacted and non-compacted samples. From these, compression index and recompression index are calculated. And it can be seen that compression index of the sample that was subjected to dynamic compaction has reduced to about 50% of that of the non-compacted sample. And recompression index of the non-compacted sample is only about 10% of its compression index. So reduction of primary consolidation settlement of waste achievable by preloading is much greater than that of the dynamic compaction. So here you can see the coefficient of volume compressibility plots, and coefficient of volume compressibility values in decreased as effective stress increased in both samples. The MV values of non-compacted sample during reloading increments are much smaller than the compacted sample, indicating that the compressibility of municipal solid waste can be reduced more by preloading. These are the plots for variation of secondary consolidation. Both dynamic compaction and preloading have caused a significant reduction in C alpha values, but coefficient values in reloading increments with higher over-consolidation ratio are much smaller compared to that of the compacted sample. Moving on to the variation of coefficient of coefficient of consolidation. In the soil engineering practices, Taylor's square root of time fitting method and Casagrande logarithm of time fitting method are the two widely used methods to find coefficient of consolidation. But when the shape of the settlement curves do not conform to the standard shapes proposed by Casagrande and Taylor, such as in municipal solid waste, rectangular hyperbola method and improved velocity method can be used as better alternative methods. So these two were used in our study, and these are the CV plots obtained by rectangular hyperbola method and improved velocity method. Coefficient of consolidation values observed by both methods are showing the same trend on increasing stress levels, and apart from the initial stress increment, coefficient of consolidation values are of the same order at the higher stress levels. And these values are quite high as compared to the conventional soil, and this indicates that the pore pressure dissipation during an improvement process would be quite rapid. So in the previous studies of using in situ dynamic compaction, they have not established the compressibility characteristics after the compaction of the waste fields. So we were unable to compare the results of our study with them. And in conclusion, compressibility characteristics of municipal solid waste can be improved significantly using both preloading and dynamic compaction. According to the results observed in this study, preloading can be considered as the more effective method. Considering the time it takes to achieve the required compressibility reductions by preloading, dynamic compaction can be considered as another advantageous option. However, depending on the composition and the degradation level of the municipal solid waste samples used, these results can be changed. So it is necessary to conduct this research using municipal solid waste samples in different degradation levels and in different landfills in Sri Lanka. And that's the end of my presentation. Thank you.